Hi, it's time for another math easy solution. Today I'm going to go over a pretty interesting video, and this is going to be on calculating 10 to the power of 0.1, 0.2, 0.3, etc. all the way to 0.9 by hand. And it's actually going to be more of an approximation and not calculating exactly because it's apparently not possible to do so. Alright, continuing further. So as always, if you don't have time to watch this whole video, you could play this video at a faster speed. You could also download and read the notes, or read the notes on the Hive blockchain, or watch a video in parts. Timestamps and links will all be in the description below. Alright, let's jump right in. So this was a video request actually. So I was asked to make this video by OmegaKlass on BitChute. He said, here's a good possible next video. Why is 10 to the power of 0.1 equals to 0.2589? The calculator solves this easily, but the longhand method would be interesting to review. And I said that's an interesting idea. I may do it actually. I've done several videos on calculating square roots by hand before. You can see this one here as a method for square roots. But for 10 to the power of 0.1, etc., it's not that straightforward. So note here, so let's just go ahead and jump right into this. So note that I borrowed a lot from this article from the artofmemory.com. And note also that according to ChatGPT and pretty much mainstream sources online, it is not possible to calculate 10 to the power of 0.1 by hand directly in the same way that we can for division or multiplication. You're going to need a Taylor series or logarithms, etc. to do so. So you can't just do it as you would for division or multiplication by hand. Yes, but nonetheless, an approximation would still be pretty good doing it by hand. So let's do a calculation check first using my built-in OneNote calculator. So if you go 10 to the power of 0, that's just going to be, well, that's just anything power of 0 is defined as 1. And if you go 10 to the power of 0.1, you just press space here, it goes 1.2589. All right. Doing that for the rest, you get these all the way to 10 to the power of 1, which is just going to be, well, 10 to the power of 1 is just 10. And I've bolded the ones that are interesting that we're going to use for approximation. So note here, 10 to the power of 0.3 is equal to 1.9953. And then 10 to the power of 0.6 is equal to 3.9811. And 10 to the power of 0.9 is equal to 7.9433. In other words, this right here is approximately equal to 2. This is approximately equal to 4. So this is 2. This is 4. This is approximately equal to 8. In other words, this equals to 2 to the power of 1. This equals to 2 to the power of 2. This equals to 2 to the power of 3. So yeah, 2 times 2 times 2. Like that? Alright, so that's what I wrote here. So note that 10 to the power of 0.3 is approximately equal to 2. Let's use this for our approximation. So yeah, so basically we're going to use one calculated formula and then use that to calculate these others by hand. So that's what I mean. It's not that straightforward as division or multiplication. So you're going to need to know something initially. So you're going to need 10 to the power of 0.3. We're going to approximate that to equal to 2. So note also, just to grasp what this means though, so note that 10 to the power of 0.3 means a number multiplied by itself 10 times and equals 1,000. In other words, 10 to the 0.3 equals to 10 to the, well, just 3 over 10. So 3 over 10 is just 0.3. And this equals to, let's say this equals to a number x. And what this means is, well, if we were to take this to the power of 10 on both sides, so if we go 10 to the 3 over 10 to the power of 10, and then on both sides, so x to the power of 10, this would equal to, well, this would cancel out. So you're just going to be left with 10 to the 3. This equals to 10 to the 3. And this equals to, well, you could just put this, do it in your head. It's going to be 1,000, or 10 to the 2 times by 10 using our power rules. This equals 10 to the 1, add those up is 3. So this equals to just 100 times it by 10. So that's just 1,000. So in other words, we're going to have a number multiplied by itself 10 times. So this just means right here, this equals to x times 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 x. So 1, 2, 3, 4, 5, 6, 7, 8 times x, that's 10 equals to 1,000. So, so finding this is not that straightforward to a division or multiplication. So yes, you're going to do that 10 times. That's what this means. So if you ever want to grasp what that means, that is what this means. Finding x such that multiplying it 10 times equals to 1,000. All right, now back to our approximation. So we're going to use 10 to the power of 0.3 is approximately equal to 2. And then if we use this definition, well, just what it means, the number multiplied by itself 10 times equals 1,000. But in this case, because we're approximating it, so to the power of 10, put that in a calculator. This just equals to 1,024. So you can see this is off by 24. So that's the whole that's the whole idea of 10 to the 0.3, what that means. Going further, so note the actual value is, so if you put in the calculator right here, 10 to the 0.3, you get, this 1.9953. So it's not exactly 2, but it's close enough for our purposes. And now if you were to go 1.9953 to the power of 10, this equals to, if you press space, equals 1,000.1889. My one calculator, my OneNote calculator rounds up the figures, is actually just equal to 2. So what I'm gonna do is I'm just gonna erase this, and I'll just put a note here. My OneNote, just ignore that. And so just trust me. So that's the actual number is gonna be equal to, is equal to, put like that. It equals to 1,000. Anyways. All right, for completeness sake, let's just do this right here. So if you plug in Google right here, 10 to the power of 0.3, you're going to get this 1.99526. If you copy this right here, so just more decimal places accurate. So 10 to the power, this number to the power of 10 equals to 1,000, 0.000, etc. Again, some rounding issues, but exactly 1,000. Is epic stuff. So thus we have an error of, so to get the error, we get the approximation. We're going to see the difference. This is our approximation 2 minus this right here, 1.9953, and then divide that by 1.9953 times by 100 to get percent, and we get this number right here. If you press space, automatically calculated. So it equals to 0.2356, which is round up to 0.24% approximately, equal to that. So that is the error that we're going to get, and we can apply correction later if we want more precise manual calculation. So, anyways, going further, so this means that we want to be more precise. That if we want to be more precise, we have to subtract our approximations by 0.24% each time we multiply it. So let's approximate multiples of 10 to the power of 0.3. So what I mean by this is, well, first of all we have 10 to the power of 0.3, this approximately is equal to 2. All right, so we have this. We're going to bold that in like that. The next one is going to be, 10 to the 0.3. I'm going to multiply this by 10 to the 0.3. So 10 to the 0.3 times by 10 to the 0.3, this equals 2. These add up using our power rules. This equals to 10 to the power of 0.6. And then this equals to approximately equal to, we're going to multiply this twice, so 2 times 2. In other words, this is just 2 to the 2. So this one is equal to 2 to the 1. This is equal to 2 to the 2, and this equals to 4, like that. And now if we multiply it again, or we could, instead of writing this all out, we'll write this one out. And then, so we're going to go 10 to the 0.3, or actually 10 to the 0.3 times it by 10 to the 0.6. 10.6 like that. This equals to, these add up, equals to 10 to the 0.9. So this is going to be approximately equal to, now we're going to go, this is going to be 2 times 2, or just 4 times 2. This is, you can just be, write this here. This is going to be, right for completeness, this is going to be 4 right here, times by 2, and again, this just equals to 2 to the 3. This equals to 8. Like that. So, so that's what we have, these ones here, and the reason I got these ones is that's the one I bolded right here. So we have the 2, 4, 8 like that. There's our 2, 4, 8. All right, and now going further, so these are the 0.3. These are just multiples of the 0.3 powers. But to get the powers such as 0.2, 10 to the 0.2, we have to apply a pretty neat trick. So going further, we can divide by powers of 10 to obtain powers such as 10 to the power of 0.2. So for example, to get that, we'll just continue further. So the next one here. So this is 10 to the 0.9. We're going to multiply it again. So we're going to go 10 to the 0.3 multiplied by 10 to the 0.9. And we're going to get a power such as this one right here, 10 to the 1.2. Those add up. This is going to be 9 plus 3 is 12. We put a decimal place there. This approximately is equal to, it's going to be 8 times 2. 8 times 2. And this equals to, well, it's the same thing as multiplying this by another power. So it's 2 to the 4. This equals to 16, like that. And so that's what we have there. But notice what we can do right here. This is 10 to the 1.2. So what we'll do is, to get the other power, we're going to go 10 to the 1.2, divide this by 10, or 10 to the power of 1, and this means we could subtract powers. So if you multiply 10 to the power like that, if you're multiplying powers, you add them up. If you're dividing these powers, you're going to subtracting these. So 1.2 minus 1, this equals to 0.2. Yeah, so then this means this is going to be approximately equal to, well, 16 divided by 2. And 16 divided by 10. So we're going to do this on both sides. So 10 to 1.2 divided by 10 and 16 divided by 10. So this equals to 1.6. So we got it for 0.2. So 10 to 0.2 is 1.6. And we can see that in our exact numbers. So 10 to the 0.2 is 1.6 approximately, or 1.58. So that's epic stuff there. So now let's do it. The next ones. And yeah, we'll just do the whole thing for completeness. The next one's going to be right here. Multiply this again. So 10 to the 0.3 multiplied by 10 to the 1.2. This adds up to be 10 to the 1.5. And then this is approximately equal to 16 times 2, or equals 2 to the 5. Like that. And this equals to going to be 32. Like that. And now just noticing the pattern, we can just go, well, this was 0.2, we get, this is 1.2, then this becomes 0.2, this is 1.5, that just becomes 0.5. So in other words, 10 to the 0.5, this approximately equals to 32 divided by 2, by 10, which equals to 3.2, like that. And again, for completeness, let's just write this out. So 10 to the 1.5 divided by 10 to the 1, or 10 to the, 10 to the, like that. Alright, so this is 10 to the 0.5, that's 3.2. Let's go back up here, 10 to the 5, 3.2. So that's just close enough, 3.1623. So if we go, let's keep going like this until we get all the numbers within the 10 to the 0.1 to 10 to 0.9. So it's going to be quite a while. So let's go another one, 10 to the 0.3 times by 10 to the 1.5. This adds up, equals to 10 to the 1.8. And this is approximately equal to 32 times 2. Again, and then write it in the other format, 10 to the 6. This equals to 64. Like that. That's 64. And then, so again, we know that this is going to be 10 to the 1.8 divided by 10 to the 1. This equals to 10 to the 0.8. And then this is approximately equal to 64 divided by 10, which equals to 6.4, like that. And again, scroll back up, and we get 6.3096 is 10 to 0.8. So 6.4 is close enough. All right, let's just keep powering through the next one. So we hop in like that. 10 to the 1.8, make this neater. 10 to the 1.8, or actually, I mean 10 to 0.3 times by 10 to the 1.8. This equals to 10 to the 2.1. This approximately equals to 64 times 2. Again, this equals to 2 to the 7. Just keep that in mind. This equals to 128. Like that. So that's 128. And then this gets it over here. This becomes, again, the same thing. But now instead of dividing by 10 to the 1, because we have a 2 there, so we just go 10 to the 2. So there it is. We divide it by 10 to the 2, so that these subtract 2.1 minus 2 is equal to, well, 0.1. So now we have our 0.1 there. Does our 10 to the 0.1? So this approximately equals to 128. Since we divided by 10 to the power of 2, this also equals to, this also has to be divided by 10 to the 2. And 10 to the 2 is just 100. And let's divide this by 100. We move the decimal place twice. So 1, 2, all the way until equals to, well, 1.28. So there's our 10 to the 10 to the 10 to the 0.1. And if we scroll all the way back up, we get 10 to the 0.1 is equal to 1.2589, and we had 10 to 128. So it's pretty close. That's pretty close. 1.28, 1.2589. So it's close enough for most applications. All right. So the next one, let's go to the next. There's going to be, I think, 2 more. 10 to the 0.3, again, times by 10 to the 2.1. This is equal to 10 to the 2.4. Add those up. This approximately equals to 128 times by 2. This equals to, I think it's 256. And this equals 2 to the 8. Equals to 256. So again, 2 times 2 is 16. carry the 1, 2 times 2 is 4, add the 1, 5. Yeah, so put that here. 2 times 8, 16. 2 times 4, add the 1, it's going to be 5, and then 2 times 2 is 2. So that is this. And then the next one is going to be 10 to the 2.4 divided by 10 to the 2. This equals to 10 to the 0.4. So this approximately equals to 256 divided by 10 to the 2, or 100. This equals to 2.56. So epic stuff like that. All right, and now the last one, I believe that's going to be 10 to the 7, 0.7. And that's because, well, 2.4 add another 0.3 is 2.7. So we go, the last one, 10 to the 0.3 times it by 10 to the 2.4. This equals to 10 to the 2.7. This approximate equals 256 times by 2. And this equals to, well, 2 to the 9. This equals to, well, this is going to be 2 times 2 is 12. Carry the 1, 2 times 5 is 10. Add the 1. And then 2 times 2 is going to be, it's going to be 10. Add another 1 there. And then it will carry the 1. So 2 times 2 is going to be 4. Add 1, 512. Like that. So we have 512 here. And this, again, the last one's going to be 0.9. Yes, we need to get to 0.9. So 2.7. So to get to 0.9, we go 10 to the 2.7 divided by 10 to the 2. And this is equal to, subtract those, 10 to 0.7. This approximately equals to 512. Divide this by 100. So this equals to 5.12, like that. All right, so now that we have all that, so let's put this in a table. So thus, before we apply our correction, we can summarize our results as follows. So again, 10 to the 0.0 is just 1, and then 10 to the 0.1 is approximately equal to 1.28. And this is from, again, 10 to the 2.1, which is approximately equals to 2 to the power of 7, which equals to 128. Let's go over here. That was this one right here. 10 to the 2.1, 2 to the 7, 1.28. The next one is 10 to the 0.2 is 1.6. And this was from 10 to the 4. So that is from this right here, 1.2 to the 4, 16, 1.6. And then the next one's, this is our starting approximation, 10 to the 0.3 is equal to 2. Next one's 2.56 is 10 to the 0.4. And this is from, this is 2 to the 8. So that was right here, 2 to the 8. And this is, 2 to the 8, we get this 10 to the 2.4. To this, divide this out by 10 to the 2, get 10 to the power of 0.4, 2.56. All right, the next one is 3.2. That's 10 to the 5, 3.2, and this is, we have this over here, 2 to the 5. Yeah, 3.2 to 10 to the 0.5. The next one is, this is our approximation from this one, just multiplied by 2. This one's multiplied by 2, 10 to the 7. That is our 2 to the 9. That's right here. And then 10 to the 0.8. That's 6.4, 2 to the 6. And 2 to the 6 is this one right here. And that's that is from 10 to the 1.8. So now note the pattern that we can memorize, keep it in memory. And if you want to multiply it by in your head, you can quickly know it just for starting from this right here and noting the pattern. So find a multiple of 3 that ends with the desired number you want. Yeah. So in other words, so right here, this one here, 0.1 was derived from 2.1. So notice the ending 1 here. This is 1. Notice here, 0.2. This ends at 2 and at 1.2. This is 0.4, 0.4, 0.5, and this is 0.5. And this one right here, 0.7. This is 0.7. So in other words, we want a multiple of 3 because we're all just multiplying by 0.3. But yeah, a multiple of 3 that ends with a desired number you want. And again, this could be more specifically 0.3, but yeah, just multiple of 3, and then you can deal with the decimal places yourself. So, for example, let's say we have 10 to the 4. Just try to using the pattern. So 10 to the 4, we want a number that's a multiple of 3. So 3 times a number blank equals to a number blank that ends with 4. That ends with the number we want. So it has to end with 0.4, so it ends with 4. Like that. So in other words, well, 3 times what? 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is going to be, it's going to be 12. So we're obviously going to keep going until we get 3 times 8, which is 24. Yeah, so we just need to know a multiple of 4. So this is going to be, this is going to be, just for use your memory, and this is going to be, because we're dealing with 0.3. So to be complete, we could just put this like this. 0.3. So we want multiple of 0.3 just to be complete, but I just kind of ignored like that. This equals to 2.4, right? Yeah, so this just becomes, we just make a divide by 10. So then what this means is we get from 2 to the 2.4, and this approximately equals to 2 to the 8. So in other words, this 4, this right here, this 4, or this whole 2.4 right here goes here. This 8 goes here, and this approximately equals 2 to the 8. And again, this one's equal to, well, we know this is 2 to the 2. And just do this in our head. We already know what it should be. 2 to the 2 is equals to, I guess number add these up is 8. This is going to be 4 times 4. That's 4 times 4. This is equals to 16 times 16. Times 16. Let's do this in our long multiplication. 6 times 6 is 36. Carry the 3. 3 times 6 is 6. Add the 3 is 9. Next one, add the 0. 1 times 6. 1 times 1. Add these up, 6. 9 plus 6 is 15. 5. Add 1, 256. So in other words, this equals to 256. And then you're going to have to divide this to get to 0.4. So 10 to the, and I'm doing this all slowly, but you can do this all in your head quickly and you just know the pattern. Divide this by 10 to the 2. This equals 2. 10 to the 0.4. Approximately equal to 256 divided by 100. Because 10 to the 2 is 100. This equals to 2.56. You guys do it all in your head. And again, that's just 10 to the 4. Again, from 10 to the 2.4, it approximately equals to 10 to the power of 8 equals 256. All right.
All right, now to apply the correction. Note that we have to multiply the correction each time we multiply by 2. And note 1, I'm using OneNote's built-in calculator for the correction calculations, but you may readily do them by hand or find other tricks outlined in the reference article to calculate by hand or mentally. And note 2, I also round up to 0.25% to make the error calculations even easier here. And also note 3 here, if you notice my voice has changed, I'm actually editing this video a week after because I thought I just fixed this up. And I have been sick, so my voice is is a bit out there. But anyways, let's continue further. So applying the correction. So here's applying the correction of the 0.24, and then I have it with the doing it just 0.25, so it's easy to calculate that full error. So for example here, so 10 to the 0, that's just is 1. Then 10 to the 0.1, this is roughly equal to 1.2. That was just a simple estimate. That's just 1.28. Yes, a 1.28. And then what we could do is, so we would have to subtract by 0.24% times by how many times we had to multiply it. So if you look at the 10 to the 0.1, we had to apply the error 7 times. So that means, this was derived from 2 to the 7 equals 128. So that means we have to multiply by 7 times. In other words, we're going to have to go 1 times and then 1 minus this right here, just so that this means that we're going to be subtracting 1, which is just the with no error, and then 7 times 0.24. And then if you plug in your calculator, here, this one here is built in. It just automatically calculates 1.2585. And if you want to go even quicker than that or simpler than that, this is approximately equal to 1.28 times by 1 minus, and then this is 1.75%. And this one is just, if you round this up to 0.5, and then you'll have right here, 7 times 2.5. Well, 8 times 2.5 is 2, so you just subtract another quarter. So that's just 1.75. And then plug in the calculator, you're going to get this. But if you want to do it by hand, it's easier to do this 1.75 as opposed to 7 times 0.24. So you could just go, let's go this one here, subtract by 1.75%. So that's just an easier way if you wanted to solve that. All right. The next one, 10 to the 0.2 is approximately equal to 1.6, and this was derived from the 2 to the 4. So that means we're going to multiply the error 4 times. So we have to subtract that error 4 times 0.24%. We get this number. And it's approximately equal to, also, if you want to go even simpler, 1.6 times 1 minus, and then it's going to be 1% off. Because this is 4 times 0.24, rounded up to 0.25, so just subtract it by 1%, and you're going to get 1.584. And this one is easier to calculate by head or by hand. Anyways, and then the next one here is the 10 to the 0.3. This is the one we start off with. And this one is just the error 1 time. So this is 2 times 1 minus 0.24. Yeah, 0.24%. That equals to 1.9952. Or you can go just 1 minus 0.5%, and it just rounds it up to 1.995. Like that. And then the next one, 10 to the 0.4. This is 2.56. And this is applied there 8 times. And this one, 8, this just means it would be 2%. Or this is approximately 2%. And this one, this would be subtracted by 2%. So this is right here, 2.5108. Or apply it simplified to 0.25, you get 2.5088. Anyways, the next one is 10 to the 0.5. This equals to approximately equal to 3.2 times it by 1 minus. And now we can do the error 5 times. So applied 5 times, and 5 times it would just be 1.25% when you round it up. That's because 5 times 4 would be 1, and then add another one. And you get 3.16. Here's just with the normal error. 3.1616. And then 10 to the 0.6. This applies error twice. So that we're going to get 3.9808. This approximately equal to, again, just 4 times the error right here, which is 0.5%. This is just because you apply twice. So 0.5, and you can round it up like this. So it depends on, this one is if you want to do it on your head, and this one if you're a calculator, just do it like that. Or you can do it by hand, more tediously. But anyways, 10 to the 0.7 is 5.112, and then minus, and then 9 times the error. And you could also, the error, 9 times the error, 8 would be 2, and then add another 0.25. So you get this right here, and you get 5.0094 or 5.0048. And then 10 to the 8, this is the error 6 times. So you're going to subtract that error, 6 times that 0.24% or 0.1 or 0.25%, which is 6 times of that is going to be 1.5% error. So basically, the answer is 6.4 minus 1.5% error. All right, going further, 10 to the 0.9. This is just equals to error 3 times. So you have minus error 3 times, you're going to get 7.9424. Or you can go, 0.7, subtract by 0.75%, just to make it easier. You get 7.94. And then the last one, 10 to the 1 is just 10. And then if you compare all of these, let's compare approximations with the exact figures. So here is the simple one. Here's the correction. This is just using the 0.24%, using these. But again, you could pick those if you want. And just to show you the actual numbers, and then with the actual, with the correction, with the simple one. So here's here's a simple one right here. This is one. All of these are just going to be 1, 10 to the 0s of 1. The next one, 10 to the 0.1 is 1.28, or you get 1.585. 1.2585 like this. Or you get 2576 if you want to go with the other one, but we'll just ignore that for now. The actual is 1.2589, so again, very, very close to the actual number there. Then 10 to the 0.2, 1.6, or 1.5846. The correction, 1.5849, so again, very close. 10 to the 0.3, the simple, this is all based on this assumption. We just assume that this equals to 2, and then go from there and then apply the correction. So the correction, once you apply the correction, is actually off by 0.24%. So 1.9952, or the actual is going to be 1.9953. It's rounded up a bit higher there. The next one, 10 to the 0.4, you get 2.56 is the simple. The error, 2.5108, or the actual, this is the correction one, this is the actual, this is 2.5119. Or you go 10 to the 0.5, 3.2, or 3.1616, and then the actual 3.1623. So again, these are very, very close there. And then 10 to the 0.6 is 4. The simple one, I like the simple one better. It's close enough. 1.9952, it's close enough to 2. 3.9808, it's close enough to 4 in my humble opinion. So then this is going to be the actual is 3.9811. And then 10 to the 0.7 is 5.12. Or then the correction, 5.0094, and then 5.000119. Then 10 to the 8, 6.4, 6.3078. or 6.3096. And then 10 to the 0.9 is 8, or 7.9424, or 7.943 is the actual. And then 10 to the 1, all of them is 10, 10, 10. All right, that is all for today. Hopefully you enjoyed this this very interesting type of video. And yeah, so I think if there's anything that you got along from this video, it's in my view is that what this number actually means. So 10 to the 0.3 means a number multiplied by itself 10 times and equals 1,000. So that's a very, very a good takeaway to take home with yourselves there. So this just means you're gonna have a number multiplied by itself 10 times, and then you're gonna get that 1,000. So that is what that means, which is pretty interesting there. And then also you could approximate this with just using one approximation, or just finding one exact calculation, or approximate this one. You're 10 to the 0.3 equals 2, and then from there you can just start doing everything in your head, or just approximately, and so on. And then also, and also understanding the error too. So if you're gonna assume it's 2, and then if you go back to what it's defined as, so 2 to the 10, you're gonna get 10 to 4, so you're gonna be off by 2, 4 there, as opposed to getting exactly 1,000. Anyways, that is all for today. Hopefully you enjoyed, and like always, you can download these exact notes in the link in the description below. And thanks for watching, and stay tuned for another Math Easy solution.